students, welcome back to Chemical Kinetics. We are dealing with zero order reactions, and here in this module we will study half-life of a zero order reaction, and we will see how to represent this half-life graphically. So let's get started. In order to understand half-life for a zero order reaction, first of all, it is important for us to remember what is half-life. And as we know, half-life for a reaction is the time taken for initial concentration of the reactants to reduce by half of its initial value. We also know that for a zero order reaction, this is the integrated rate law. K is equal to C naught minus Ct upon T. Now this equation, the integrated rate law equation, can be rearranged and can be written as C naught minus Ct is equal to Kt. Now here, when this reaction reaches its half-life, I can say that T will become T half, because that's the half-life. Also, I can say that Ct will be C naught upon 2. That's because at half-life, the concentration of the reactants reduces by half of its initial value, which means half of it is left. If I substitute these values in the integrated rate law, I will get C naught minus C naught upon 2 is equal to K into T half. Now here, if I take the LCM on the left hand side, I will get C naught upon 2 is equal to K into T half. Which means that if I rearrange this equation, I will get T half is equal to C naught upon 2K. Now here, this equation, T half is equal to C naught upon 2K, is the equation for half-life for zero order reactions. So as compared to a first order reaction, if you observe this formula, now let's have the formula here, T half is equal to C naught upon 2K. If you observe this formula, you will see that the half-life for a zero order reaction is directly proportional to its initial concentration. That's one thing, because C naught is in the numerator. So if C naught value is more, T half value will also be more. So I can say that half-life for a zero order reaction is directly proportional to its initial concentration, and also it is inversely proportional to the rate constant, since rate constant is in the denominator. In fact, since T half is directly proportional to C naught, if I plot a graph of T half versus C naught, this is the kind of graph I will get, T half versus C naught. Now here I know that T half is directly proportional to C naught, which means this is the kind of line that I will get. So if C naught increases, T half also increases. And that's exactly what you mean by directly proportional. So this is how half-life of a zero order reaction is represented graphically. Now my dear friends, with this we conclude zero order reactions. What you can do is, you can write down all the formulae of first order reactions and all the formulae of zero order reactions. Try and understand how we got them. Try and memorize them. That will definitely help you with the numericals. See you in the next module. Until then, take care.